Hey guys, welcome to Monday, March 30th stats video. We're going to start Unit 6, which is Chapter 6 in your book. And it's all about our friend, the normal distribution. We've talked a little bit about normal distributions, but now we're going to talk more about them, and we're going to get more into z-scores and how you can find them and all that fun stuff. Nothing hard, but you should be able to do this pretty straightforward today. I'm going to try to keep the video short, under half an hour, and hopefully, you get what you need out of this, and you can pause whatever you need to pause and all that fun stuff too. So, let's talk about the normal distribution. Okay, so there are 8 things about the normal distribution that you need to know. Okay. The first thing that you all should probably know is that it is bell-shaped. And I think you all understand what that means. Okay? Which, if it is perfectly bell-shaped, which a normal distribution should be, that means that the mean, the median, and the mode are all equal. Okay? Part 3 means it's unimodal. The prefix uni means one, and of course modal means one mode. Number 4, because it is bell-shaped, it will be symmetrical about the mean. Okay, the 5th thing that you need to know. It is continuous, which means no gaps whatsoever. It never touches the x-axis. Okay, the area under the curve equals 1 or 100%. And last but not least, the empirical rule applies. And for those of you who don't remember that, 68% of the data is within plus or minus 1 standard deviation. 95% of the data is within plus or minus 2 standard deviations. And of course, 99.7% of the data is within plus or minus 3 standard deviations. Now there's some things I'm going to be skipping over, but it would be really good if you read your book. I know that you have them at home because I told you to do that at the very beginning. Okay. As you all know, this is what a normal distribution looks like. It is bell-shaped, etc. Okay. This could be, for example, we could have a mean of 95, and we could have a standard deviation of 100, or we could have one standard deviation of 7. So then this would be 102 on the right-hand side, and on the left-hand side we'd have 88. And then this area in between in the curve would be 68% of our data. Another way of saying that would be to say that there is a 68% probability of the data of a data point falling between 88 and 102 in this particular set of data. Now what we are going to do is we are going to standardize. So we need to standardize our normal distribution. What does that mean? That means that we are going to slide it so that the center is at mu equal to 0. And we are going to change its shape. So we're going to shape it, but it's still going to be normal, so that sigma is equal to 1, or the standard deviation is now 1. Okay? So when we have the standard normal distribution, we have mu equal to 0 and sigma equal to 1. Okay. Hopefully that makes sense. So, let's say that we have another standard distribution, a normal distribution. Sorry, a normal distribution, and the mean is 87. And we have a sigma of 4.2. And let's say we want to know what percent of our data would be greater than a score of 95 on this normal distribution. Okay? So what we would need to do, or in other words, we want to know the probability of x being greater than or equal to 95. Okay? So what we're going to do is we have to standardize it. Okay? Well, what does that mean? Well, we need to actually find the z-score. And guys, you know how to find a z-score. We've talked about this over and over already. Remember, a z-score is just simply our observed minus the expected divided by the standard error. Okay? So in this case, our z-score is going to be our x minus mu over sigma. Our x value that we're looking for is 95. Our mu is 87, because that's our mean, and our standard deviation is 4.2. Well, if you do the math, 95 minus 87 is 8. 8 divided by 4.2 turns out to be 1.90. So we end up with a z-score of 1.90. So this particular normal distribution, when we standardize it, simply looks like this. We have our mean is now at 0. Okay. And this is our z-score. In this case, with the value of 95 that we're looking for, our z-score is going to be 1.90. Okay? So the probability of getting a z-score greater than or equal to 1.90. Okay? Now, we still don't know what the probability of that is. Now, we could use calculus, but, not many of you have actually taken calculus. I know you have, Kieran, but we're going to make our life easy. Okay? We are going to use our blue charts, and hopefully you all have your blue charts at home. Okay? Now, this might be a little bit tricky, so we're going to see how this works. Okay? So I'm going to see if I can make this a little bit bigger so you can look at it. Now, what do I know? I know my z-score. My z-score is 1, so I come down here to 1.0, 0.9, so I go all the way over to my bad. I know my z-score is 1.9, so I go down to 1.9, 0. Okay? Now, look at this picture up here. Notice what's filled in. Everything to the left is what's been filled in, correct? Hopefully you're looking at this on yours as well. Notice everything is to the left of the z-score. that means that the probability is to the left of that number. Okay, so this number that I have for 1.90, 0.9713, okay, that 0.9713 represents everything to the left of z. But I don't want to know the probability to the left of z. I want to know the probability to the right of z, don't I? Well, how in the world could I figure that out? Well, it's pretty easy. What did we say up here that the area under the curve would have to be? 1 or 100%, right? So what's left to the right of z is just simply 1 minus 0.9713. Hopefully that makes sense to you guys. So how in the world do I figure that out? Well, it's pretty simple. Use your calculator. What is 1 minus 0.9713? Well, it's 0.0287. So the probability in this case of getting a score of 95 or greater is pretty low. It's actually 2.87%. 2.87%. So if it's a normal distribution, after it's been standardized, you would have a 2.87% probability of getting a score of 95 or higher based upon this particular set of data. Does that kind of make sense to you guys? I hope so. All right, so let's just start, okay? We're going to start with a given z value, okay? So we're going to give you a little picture, okay? Now in your homework I didn't draw any pictures, I just gave you numbers, but you should understand. We have 0 and we have 2.55. That is our z-score. This is a standardized curve, and we want to know the probability between 2.55 and 0. Okay? Well, what do you do? Here's your z-score. You look up 2.55. Okay, so here's our little chart again. We'll find 2.55. Okay, we come down here to 2.5. And we move over to 2.55. And we have a probability of 0.9946. Okay, 2.55 is 0.9946. Again, I'm hoping that you're looking at these with your blue sheets too. So 0.9946 represents the area to the left of 2.55. Okay, so we're talking to the left of 2.55. Unfortunately, we don't want all the area to the left of 2.55, do we? This is all of the area to the left. So what does that mean for us? Well, we only want from the mean up to 2.55. What did we say the area of the whole thing was? We said the area of the whole thing was 1 in total, correct? If it's symmetric about the mean, that means that to the right of 0 is 0.5 of our data, or 50%, and to the left is also 50%, correct? So all we have to do is take our 0.9946 and subtract the 50% that we don't want, because it's not in the range that we're looking for. So we just simply do minus 0.5000, and we end up with 0.4946, or 49.46% of the data lies between 0 and a z-score of 2.55. That kind of makes sense? I'm listening for a yes, but I know I'm not going to hear one. It's okay. All right, so let's do another one. Let's do the probability of negative 1.48 being less than z, which is less than 0. Okay. So what I would like you guys to do on your own paper, when you get these, draw the picture, draw the standard normal curve, or draw the standard normal curve. Okay. And what are we looking at? We're looking at 0, and we're looking at negative 1.48. And we want the area in between, don't we? So there we go. Okay. Now this becomes a little bit tricky. All right. There is a negative 1.48 on our blue sheet. Okay. And as I zoom in once again to try and get this for you, I go to negative 1.4 over to 8, and I end up with 0.0694. So I'm going to write that number down, 0.0694. Okay. Now, remember, again, this 0.0694 is to the left of negative 1.48. Okay? So we don't want that area, do we? We only want everything from the right of from negative 1.48 up to 0. Again, from 0 all the way to the left is 0.50, or 50%. So if I take my 50% from here and subtract off 0.0694, or 0.5000 minus 0.0694, what should I end up with? Well, once again, I should end up with this area in between, because remember, from 0 all the way to infinity is 0.5. From left of negative 1.48 to infinity is 0.0694, so I'll just subtract those two, and it'll end up with 0.4306. So the probability of getting a score between negative 1.48 and 0 is just simply 43.06%. And again, these are standardized scores. These are scores with where our normal curve has already been standardized for us. We're giving you z-scores. We're not giving you observed and expected at this point. Okay, let's do one more. Let's say you have the probability of z greater than or equal to 1.25. So again, I strongly recommend you draw yourself a picture. Okay, here's 0. Here is our 1.25, and again, I'm not looking for perfection. You don't have to measure it out, but I always shade in what you're looking for. So I'm looking for greater than 1.25. If I look on my blue chart and I find the number 1.25 and I find the probability that goes along with it, does that represent to the right or to the left? I'm really hoping you're saying that's to the left, because everything on that z-chart is to the left. Okay, so let's go ahead and find 1.25 on our z-chart. Here's 1.2, and I go over to 5. So that probability is 0.8944. So I'm going to write down right under there 8.8944. Once again, that represents everything to the left. Well, how am I going to figure out what's to the right? Well, that's pretty straightforward. What's the entire area of this curve? It's 1, correct? So all I have to do is subtract 0.8944, which is everything to the left of my z-score, from 1 this time. So I have 1 minus 0.8944, which turns out to be 0.1056. Or you have a 10.56% chance of getting a z-score greater than 1.25. Now remember, we've also talked about z-score being the distance from the mean, right? So think about this as you have greater than 10. You have a 10.56% chance of getting a score that's more than 1.25 standard deviations from the mean. All right. Well, what if we have to go backwards? What if we have to find the z-value? Given a probability. Okay. Well, this is pretty straightforward. Okay. Here's an example problem. 48.71% of the data falls between z and the mean. Okay. So the hardest part about this is going to be saying, okay, what does that mean? No pun intended. So you're going to draw your picture. You know that the mean in our standardized score is right here. So that's going to be 0. And I want 48.71% between here, or between our z-score and the mean. So I'm going to put this is our z-score, and this is our area, or our probability. This is 0.4871. So the area under the curve between 0 and our z-score is 0.4871. What does that mean? Remember, I'm looking for a z-score, but I have the area now, or I have the probability. So once again, I go back to my blue chart, okay, and I look for 0.4871. But if I do that on my blue chart, what happens? I'm going to end up somewhere in the negative zone, and I don't want to necessarily be in a negative zone. Keep in mind that this 0.4871 represents everything between z and 0, but everything to the left of z is going to be how much? Well, it's going to be 0.4871 plus 0.5, because we have half of our data over here. So what I'm really looking for our z-score is I'm looking for 0.9871. Okay, so my total area that's being represented is going to be 0.9871 on this chart. Okay, so now let's look at 0.9871 and see where we find that. All right, so we're going to zoom in, and we're going to look for 0.9871. Okay, 0.99. Here's 0.9875. Oh, look, 0.9871. If I go over to the left, that's 2.2. If I go up, that's 0.3. So the z-score that I'm looking for is 2.23. Okay, so at a z-score of 2.23, 48.71% of the data lies between that and 0. And remember, 98.71% of the data lies between z and the left-hand side of infinity. I'm hoping this makes sense to you. You can feel free to watch the video as much as you need to. Okay. Let's do one more and see what we can come up with. Okay. .51% of the data falls above z. Okay. So the first thing we need to do, of course, is what? Draw our picture. Okay. Now, here's our 0. Where's 80.51% going to be above it? Well, that's going to be on the left-hand side here. So I'm just going to put this. This is our mystery Z. And I'm going to shade in everything to the right of Z. Okay. This area represents 0.8051. But again, that is to the what? This is to the right, and our blue chart only tells us to the left. So what I should do is I should look for the Z value that goes with the part that's unshaded, and that'll give me the 0.8051. Well, how do I know what's unshaded? Well, it's simply 1 minus 0.8051, which turns out to be how much, guys? 0.1949. Okay. So now I have 0.1949 of my data to the left of Z and 0.8051 to the right of Z. So let's take a look at 0.1941. Well, I already know that's going to be over here in the negative zone. Okay, so let's see if we can find it. .1941. Well, here's some point ones. 0.1941. Oh, I'm sorry. 0.1949. It would help if I looked for the right number, wouldn't it? So here it is, 0.1949. Okay, that's negative 0.86. So my Z-score equals negative 0.86. In other words, 80.51% of my data is going to be to the right of a Z-score of negative 0.86. And that's it for this part of this unit. Okay. What I would strongly suggest you guys do is to read section 6.1 if you're having any questions about this. And there is an assignment of 10 problems, and basically all you're doing is you're finding either Z-scores, or I'm giving you a Z-score and you're finding the probability. I will be available to you Tuesday the 31st, tomorrow, from 11:30 to 12:30 online. Okay. I can't do online. I can't do video conferencing, of course, but I am certainly. I will be, at my computer answering questions for you guys specifically. You can always ask me a question anytime. I just may not be at my computer any other time. But I feel like I'm going to be spending a good 7 hours a day almost at the computer. Anyway, so if you're having struggles with this, don't worry. It's new for me too. We'll get through it together. And, there's 8 of you. And, you're all very smart and very bright. So I really look forward to going through the rest of this class with you guys. I will find out on Wednesday about what they want us to do with midterms and final exams, so you might be off the hook with those, but I'm not going to say that for sure yet. All right, I hope you guys have a great day, and look at that, I managed to keep it just under half an hour. Talk to you all later. Bye.